Hello and welcome to your week 4 algebra recording. At this time, I do want to make sure you've got your math notebook out where you will take notes as you watch this recording and include those in your week 4 notes when you go to submit those at the end of the week. Remember, you're going to have two things in your weekly notes, your notes from the Schoology lessons as well as your notes from the weekly recording. So we're going to start with a warm-up problem that I should see in your weekly notes when you submit those. Let's take a look at this warm-up problem. I've got a graph and I've got a segment graphed, segment AB. And what I would like you to do is to look at that graph, and I want you to tell me what is the domain of that graph as well as what is the range of the graph. So I want you to find the domain and the range of the graph below. So we're going to review two terms that we've learned, and that is domain and range for a warm-up. So go ahead and click pause. I want you to try this on your own, and then when you're ready to check your work with mine, go ahead and click play. So go ahead and click pause now and try this on your own. All right, so domain, let's start with domain. So what is the domain of a graph? So remember, the domain is all your possible x values. All your possible x values. You can think of it as the domain is your horizontal values, your x values. So what is the values that the graph has, all the possible x values, the horizontal values. So looking from A to B, what are my possible x values? Well, I see that the graph starts here at -3 and it's a closed circle at -3, meaning that we can include the value -3. So the values of this graph are going to include all the values from -3 all the way to, remember, we're looking for those horizontal values. So so we start at -3 and all the way to, what is that, 2, +2. And it's a closed circle at +2. So our domain is going to be all x values that are greater than or equal to -3. So greater than or equal to, it can include -3. And then it has to be less than or equal to 2. So x can include any value greater than or equal to -3 all the way up to and including +2. So any x value that falls between those two numbers, that range, is our domain. What about the range? Let's do this in purple. So remember, the range is all of our possible x, or I'm sorry, not our x, all of our possible y values. All of our possible y values, that's the range. And since we're talking about our y values, we're talking about that vertical, the vertical values. Y is talking about up and down values. So let's take a look at this graph. So from A to B, now we're looking at our vertical range here. Our vertical range here. So from A, and remember it's a closed value, all the way down to B, where B ends right here, right? This is all of our vertical values that we can have. So starting at 1, and it has to be greater than 1, but then it has to be greater than or equal to, because it can include 1 because we've got a closed circle here. So our y values have to be greater than or equal to 1, but what does it have to be less than or equal to? Well, if we go up here, we see that vertical 1, 2, 3 stops at 4. So it'd have to be less than 4, less than or equal to 4. So the vertical range of numbers is, our y values can be anywhere between and including 1 and 4. So that's our range. So a good review there of what domain and range is. You will be revisiting that this week as we start a new unit. So let's go on to the next slide and see what we are doing this week. So this week we are wrapping up Unit 5. We're going to take our test on polynomials. Remember, we learned all about polynomials. We learned how to identify polynomials based on the degree. So we looked at how to find degrees of monomials, which is a type of polynomial, as well as polynomials. What else did we do? We added and subtracted polynomials, we multiplied them, we looked at factoring and solving polynomials by factoring. So that, in a nutshell, is what we did in Unit 5. So Unit 5, before you take Unit 5 this week, make sure that you have redone any low scoring assignments, because after this week, there will not be any more redos from Unit 5. This is the last week for redos in Unit 5. And then you guys are going to start Unit 6. So you can get a really good idea of what you're going to be learning about in Unit 6 when you take the Unit 6 pretest. So remember, the Unit 6 pretest is just that. It's a pretest. So you will get full credit for completing the pretest no matter what you know or don't know, or no matter how you do on the pretest, you will get full credit. So what's cool about the pretest is, again, you get a sneak peek into what is coming in Unit 6. And then it's always really cool at the end of the unit to look back and be like, wow, I learned all this new information in Unit 6. And like, wow, I didn't know how to do any of this in the pretest, but now I know how to do it. So don't panic on the pretest. Do the best you can do, but you will get full credit for completing that. And a sneak peek into what Unit 6 is all about, you're going to see in Unit 6, Session 1, where you're going to learn about identifying quadratic functions. That's right, Unit 6 is all about quadratic functions. And guess what? You guys have already seen examples of quadratic functions when you were working in the polynomial unit in Unit 5. So let's go ahead and take a look at what is a quadratic function. So moving right along here. I am going to write down some examples of quadratic functions. So I just put up some examples of the equations of quadratic functions. So look at all three of these expressions. I've got three different expressions here. I've got x squared plus 3x minus 4. Got our second expression, which is 4x squared plus 6. And I've got my third expression, which is negative 2x squared plus 6x minus 4. So do you see any similarities between these equations? Do you see any similarities between these equations? If you said that they all have a squared term in them, which, remember, in the previous unit, we learned if we've got a polynomial, to identify the degree, we look for the largest exponent. So in all of these expressions, the polynomial has a degree of 2. Each of these expressions has a degree of 2. And that is what makes a polynomial a quadratic function. So a quadratic, again, is just a polynomial with a degree of 2. Meaning your highest exponent that you will see is going to be a 2. So a quadratic function, the highest degree or the highest exponent that you will see attached to any of your variables will be a 2 to the second power. Another way you might see quadratic functions explained is by using this equation or this function right here, that a quadratic function will be given in the standard form of y equals a, which is going to represent a number, ax squared plus bx plus c. So a, b, and c would represent numbers. A, b, and c are all going to represent real numbers. And a right here can't be 0, because if it were 0, if any number times 0 is 0, we would lose our squared term here, and it would no longer be a quadratic function. So again, in a lot of textbooks and in your lessons this week, you might see a quadratic function being described as a function that can be written as y equals ax squared plus bx plus c, where a, b, and c are real numbers. What are some examples of non-quadratic functions? Can you think of any in your head? After learning what a quadratic function is, the equation and what it looks like, can you think of what a non-quadratic equation might look like? Something like 3x to the 10th power plus 4x. That is not a quadratic function. And that's because look at this exponent here, 10. It's greater than a 2, so that's not an example of a quadratic equation. If I had 4x plus 2, that's not an example either because we don't have a squared term. This would just be a linear function. What about negative 2x to the 4th plus 3x minus 2? That is also not a quadratic function because we've got an exponent of a 4 here. And that's greater than that 2, so it would not be a quadratic function. So again, a quadratic function is a polynomial with a degree of 2. I'm going to move on to the next slide, so if you need more time, go ahead and click pause. So when we graph a quadratic function, we get a special shape. And we're going to have this same shape every single time we graph a quadratic function. And that's what we call a parabola. So we call the graph of a quadratic function a parabola. When we graph a quadratic function, we get a parabola. So just like when we graph linear functions, we get a straight line. We are also going to get a special shape when we graph quadratic functions. And look at the shape we get. So each of these graphs below is a graph of a quadratic function. There's 3 different quadratic functions that were graphed. So each time we graph a quadratic function, we're going to get this characteristic U shape. So when you graph a quadratic function, you get a U shape. And as you're looking below, you can see that sometimes that U shape opens up and sometimes it opens down. So if it's shaped like this, we say it opens up. If it's a upside down U, we would say that opens down. But regardless, we get that U shape, and it is called a parabola. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So I talked about on the previous slide that when you graph a quadratic function, you're going to get that characteristic U shape. And sometimes it opens up and sometimes it opens down. But how can we tell by looking at the quadratic function? So if we have an expression or equation that we're looking at, can we figure out whether it opens up or down? You bet we can. So first of all, let's put in opens up and opens down. So something that opens up, remember it looks like this. If it opens up. If it opens down, it's kind of our upside down shaped U. So how can we look at an equation and determine if it opens up or down? So what we're going to do is we're going to look at the leading term, or the leading coefficient. Remember we learned about leading coefficients in Unit 5? So the leading coefficient, or the leading term, is that term that's attached to the x squared term. So the x squared term, the coefficient is the leading term. I meant to say the leading I'm getting tongue-tied here. The leading coefficient is the number being multiplied times the x squared term. So we put that all together and we have the leading term. The leading term includes both the variable term and the leading coefficient. So let me put up a example of a quadratic equation. A function here. So I'll do 4x squared plus x plus 2. So in this example, remember my leading coefficient would just be 4 because it's being multiplied by the leading, the variable with the largest exponent. So the leading coefficient would be 4. The leading term is this entire term, the 4x squared. That's our leading term. So this would be our leading term. So what we do is we look at the leading term and we look to see if that leading term is positive or negative. We look to see if the leading term is positive or negative, and that's going to determine whether it opens up or opens down. So if our leading term is positive, it's going to open up. So if we have a positive leading term, it's going to open up. So remember when I said that we can write our quadratic function as a squared plus b times x, or ax squared plus bx plus c, right? So if our leading coefficient is greater than 0, then it's going to open up. It's a positive leading term. So if our leading coefficient is greater than 0, or if we've got a positive leading term, it's going to open up. Whereas the opposite is true. If we have a negative leading term, then guess what? It's going to open down. And again, if we look at our quadratic function as ax squared plus bx plus c, if that a that represents the leading coefficient, if that's less than 0, it's going to open down. So we can look at the equation of a quadratic function and right away determine if our parabola, what it's going to look like. Is it going to open up or is it going to open down? I'm going to go on to the next slide, so if you need more time, go ahead and, you know what, let's do an example really quick. So looking at this example I first put up, the 4x squared plus x plus 2, would that example open up or open down? Since our leading term is positive, it would open up. It would open up. Now I'm going to go on to the next slide. All right, so another characteristic of parabolas, the graphs of our quadratic functions, are the vertex of our parabolas. And our vertex of our parabolas really are just telling us whether we have a minimum value. Whoops, I meant to put minimum. I started to combine the two words that I was going to put up here. So vertexes of parabolas are the minimum or maximum points on our parabolas. So if we have a parabola that opens up, if we have a parabola that opens up, our vertex is going to be right here, right there. And it's going to be the most, in this case, the most minimum point of our parabola. It's all the way down at the bottom here. So our vertex is the very bottom point of our parabola, and it represents the minimum. And in this case, what is the vertex? We can identify the vertex with with two coordinates. So the coordinates here, it looks like it's at right there. I kind of covered it up with that star. It's at 1, -4. So we can identify the vertex with a coordinate, coordinates. So what about over here with this parabola? This parabola opens down, and look at our negative value of our leading term. It's a negative leading term, so we know it opens down, where over here we had a positive leading term, which made it open up. So if it opens down, we are going to have a maximum point. We're going to have a maximum point as our vertex. Our vertex is going to be right here, and what are the coordinates of that point? Looks like it's at 1, +4. So again, if our parabola opens up, we're going to have a minimum point. And if our parabola opens down, we're going to have a maximum point. And this is my vertex right here, that point right there. This is my vertex. So that vertex represents the minimum or maximum point. All right, moving on to the next slide. So if you need more time, go ahead and click pause. All right, so we learned a couple different characteristics about quadratic functions. We learned that a quadratic function, when we graph it, is called a parabola. So from a graph of our parabola, we can identify lots of different characteristics. One of the things we have not talked about is the domain and range of a quadratic function. We talked about domain and range as our warm-up so that we have reviewed the domain and range. So let's identify the domain and range of a quadratic function. So when I look at this graph, I know that a graph, I should have arrows on here because the graph never really stops. We're just getting a small view because we can only fit so much on our graph. But technically, this graph is going to keep going on and on and on and on and on off of the screen, right? It just keeps going on and on and on and on. So when we're talking about the domain or possible x values, we're talking about the horizontal. What are our horizontal possible values of this parabola? So when I look, remember my x values, they can keep going because this graph can keep going. So the domain of a parabola is going to be all real numbers because it never stops. It keeps going. So we don't have any endpoints here. Whereas the range, which is our possible y values, that does have a stopping point in one direction. And I should have said y x values up here. So my range are my possible y values. So can I go any smaller than 4? Does my graph allow me to be any smaller than 4? So I'm talking about my possible y values. It does not. So the y values has to be less than, right? Because all of our y values are less than 4. So my possible y values has to be less than or equal to 4. But what about, can it be any greater than 4? No. So my y value is going to be less than or equal to 4. I can rewrite that. I don't know why I wrote it this. It should have been y equals less than or equal to 4. I don't like that way. Either way would have worked, but it should have been this one way makes more sense. So our y values can be less than or equal to 4. It can be any value less than or equal to 4 for our range. What about my vertex? Is my vertex a minimum or maximum value? So where is my vertex? My vertex is right here. And my vertex, that's a maximum value because all the points otherwise on my parabola are going to be smaller, right? So this is a maximum value. What are the coordinates of that vertex? It is -2, 4. Then another thing we haven't talked about yet is the axis of symmetry. And the axis of symmetry is, let's do that in purple. If we were to draw an invisible line that cuts it in half, like if we were able to fold a piece of paper and one side of the parabola would fold onto the other side, that is the axis of symmetry. So the axis of symmetry is right here in purple. And we can also include the equation for the axis of symmetry. So what would the equation of this perforated or dotted line be? Well, every x value, it's a vertical line, so we know that it has to be x equals, because we have to go to x equals -2 at every point. Our y value can be anything, but the x, it always has to be equal to -2 to get that vertical line. So the axis of symmetry would be at x equals -2. Another characteristics of parabolas, graphed quadratic functions, is where it crosses the x-axis. So remember, the x-axis is this horizontal axis right here, x-axis. The y-axis is the vertical axis. So the x-intercepts are another way to look at what are the solutions. So if we were to have this equation, and if we were to factor the equation, we would find the solutions. But another way to find the solutions is to look at the graph and see where the graph crosses the x-axis. And those are going to be our solutions, or the x-intercepts. So what color have we not used yet? Green. So the x-intercepts occur where we cross our x-axis, and we do that in 2 places. So what are the coordinates there? Well, it's at -4, 0 and at 0, 0. So the x-intercepts occur at -4, 0 and at 0, 0. And again, if we were to have the equation and we were to factor it, we would find that these would be our two solutions when we would solve by factoring. And then last but not least, if we were to find our y-intercept, that is simply where, let's do that in gray, where we cross our y-axis. And in this case, we cross our y-axis at one of our x-intercepts, and that is at 0, 0. Where do we cross the y-axis? Remember, this is your x, or this is your x and that's your y-axis. So that's it. So you're going to learn more about this. You're going to review everything we just talked about in our Schoology lessons this week. So let me go on to the next slide. So if you want to copy this down, click pause so that you can take good notes and finish these up in your math notebook. So click pause, otherwise I'm going on to the next slide. All right, so for this week's key phrase assignment, I have 2 questions that you need to respond to based on this graph that I have up here, this parabola. So looking at the parabola, does the parabola have a minimum or maximum point? Looking at that vertex. And then looking at that vertex, what are the coordinates of the vertex? And that's the 2 questions you have to ask. Remember, if you need any help this week, please let me know. The only way for me to know what your questions are is if you're actively asking me. So if you have questions, make sure you ask. Otherwise, have a fantastic rest of your week.